Thank you all for being here today with me and Nicola in this last session of this track, just before lunch. Today, we'll be talking about Eclipse Hara and how it can be beneficial towards a more widespread adoption of Eclipse hawkBit by making it actually easier to develop hawkBit clients for your own use cases. I'm Matteo. I'm a software engineer at Kynetics, and I'm also one of the project leaders of Eclipse Hara. We'll start today with a very brief introduction about who we are, what we do at Kynetics, and also a very quick glance of Eclipse hawkBit for those of you who don't know it already. Then we'll dive into Eclipse Hara. We'll see how we got here and where we are going with this project, and also the possible extension points, in particular what we call the native services, and also how Hara can simplify the testing of Eclipse hawkBit. We'll conclude in the end with a few announcements in the roadmap of what we did so far. So Kynetics, we are a software company. We provide operating systems and applications for embedded systems, be it based on Android or open embedded. I'm a software engineer, so I mainly focus on the applications. And speaking of which, we have our own software as a service named Update Factory to update embedded devices remotely at scale. It is based on Eclipse hawkBit, and as we'll see, many of the features of the Eclipse Hara project were born inside Update Factory. We are also members of the Eclipse Foundations, maintainers of the project Hara, and members of the IoT and Edge native working groups, and we are also in the Edge native steering committee. So that's enough about us. Let's just look into hawkBit. So who of you here has never heard of hawkBit? So you all know about it? OK. So just say a few quick words for the recording. So hawkBit mainly provides an update server with functionality to upload and download update files for the devices. Now, a device in hawkBit can be actually anything from a very small embedded device to a more powerful controller. It also provides features for rollout management, for example, so that we can decide and choose which devices we want to update, for example, to implement Canary update. For what concerns this presentation and for what matters to Hara, we will be focusing on the DDI API, which is a set of API for the devices to interact with the hawkBit server throughout the entire update process. hawkBit, in its original design, focused on the update of the devices. But a device in hawkBit, as I said, can be anything. So the original design left out a part, which is how are the devices supposed to actually implement the update workflow on their side? How are they supposed to update themselves? So while hawkBit provides a very solid backend and a very powerful set of API, it doesn't provide reference implementations for the clients. So there is the need of several different hawkBit client implementations for different operating systems, because of course each operating system has different aspects when it comes to the update, so different systems need different clients. Now, Linux devices are already taken care of by several different projects, for example, Software Update or Rauk, but there was somehow a lack of Android clients for hawkBit. So originally, at Kynetics, we designed an Android client for hawkBit. This was an internal component based upon the DDI API that we used to support the rollouts of the updates to our customers. But then we recognized that there was actually the need not only of an Android client, but for a JVM-based and operating system agnostic library that could simplify the development of hawkBit clients for devices running a virtual machine. So this is how Hara was born. Hara nowadays is a Kotlin library, because many applications on Android are written using Kotlin. specifically designed to speed up the development of hawkBit DDI clients, and it simplifies the interaction of the DDI client, making it actually easier to write native services, which are the components that actually update the device. As I said, it is operating system independent, but it is architecture dependent because, of course, it's running on the Java virtual machine. Another important aspect is that it is agnostic with respect to the type of the update. So we can use Hara to update only an application in our system or the entire operating system. Here you can see the full picture of the workflow in hawkBit. So for example, it all starts with somehow some users updating update artifacts in the update server. This can be done through a pipeline, a built-in pipeline like here, where there is, for example,
so the update server is hawkBit in the backend?
Yeah, it can be hawkBit. In our case, it is Update Factory. Any hawkBit-based server that exposes those DDI API. As I was saying, it could be a pipeline updating an update, uploading an update file, or it could be, for example, Gradle plugins that we developed for Android Studio, for example, packing Android applications and uploading them into the update server. Now, you can see here the service, and the service is the operating system component, dependent component that updates the device. But as you can see here, the only part of the service actually interacting with hawkBit is Eclipse Hara. So as we see in a few seconds, Hara removes the need for the service developers to interact with hawkBit, which is actually a burden because the developers need to know the internals of the DDI API. With Hara, this is not true, because Hara takes care of the interaction with hawkBit. Then, of course, the service can publish the information about the update to other third-party applications, or these applications can actually configure the service to decide how the update should happen. This is done through a service consumer and through some inter-process communication protocols that, again, are dependent on the operating system. In Android, we can exchange information differently than in Linux-based systems, for example. So far, I've been saying that Eclipse Hara simplifies the interaction with Eclipse hawkBit. But what does this mean in practice? So we have here a few use cases that Hara is currently fulfilling. The most important one is probably the download of update artifacts from the hawkBit server. And then, since the server needs to update the device, it is important that this device sends constant feedback to the hawkBit server so that the users of hawkBit can actually know what the device is doing. So this feedback loop, again, it is not the responsibility of the service anymore, but is entirely taken care of by Hara. Then we have other use cases, for example, sending device attributes, which can be actually anything from the version of the operating system to sensor readings, for example, in embedded devices or in IoT devices. And finally, a device can also ask for pending actions, asking the server if there is anything the device should be doing that is not currently doing. For example, trivially update the device itself. How does Hara do this? Currently, Hara has two main components in its GitHub repository. There is a DDI consumer, which is basically a wrapper around a REST client interacting with the DDI API from hawkBit. Now, this is just a component turning hawkBit REST entities into Kotlin objects. These Kotlin objects are then used by the hara-ddiclient client API, which is the actual library, a set of interfaces, a framework towards the hawkBit update server. Now, the DDI client API, it is not based on niche Kotlin features, but instead it is based on the Atos model, which is a very well-known and well-established concurrency model with several advantages when it comes to thread management, avoiding race conditions, or ensuring consistency in the state of the various components of the application. Finally, we also developed a virtual device, which is software, a simple application, which acts as a reference implementation of how we should use the hara-ddiclient API library. But it also simplifies the testing of hawkBit features, as we'll see in the end of this presentation. So this is Hara. Hara just takes care of the interaction of the service with hawkBit through the DDI API. So now the service developers only need to take care of what matters to them, which is developing and writing the logic to update their devices. Now the service, as I anticipated, is a wrapper around the DDI logic, around Eclipse Hara, which runs in the background. It is operating system dependent because, of course, it needs to know the system it has to update. And obviously, it contains the update logic for the target. Then this service is also responsible for publishing information in the system. Now, this is done through a set of service API and a service consumer, which allow other third-party applications in the system to both configure the update process and also to query the service, for example, for monitoring purposes, to export the logs, to know what's going on, and so on. Normally, in embedded systems, we only have one application running. This is called kiosk mode. And basically, we have only one application running in the system and fulfilling all the use cases of the system itself. But the service and this application, they completely drive the update logic. On the one hand, the service needs to take care of the actual update. For example, what should we do in case of power outages, network partitions, network timeouts, or other errors? How can we ensure the consistency of the update if something goes wrong? On the other hand, the application has to take care of the interaction with the user, of the user experience. How should the user be notified that an update cannot be performed because there is a power outage, for example, or because the network communication is not working? Then the service has also to take care of more lower-level issues. For example, how can we update only an application? How can we update the entire operating system? And if we update the operating system, how is the update carried out? In several highly constrained embedded systems, we only have one system partition because we do not have enough storage space. In this case, single copy updates, the update needs to overwrite the system partition. So this is, of course, very, very dangerous because if we mess up with the update, we basically break the device. Other devices that have two system partitions can benefit from double copy updates, where we have two partitions and we write on the one that is not in use at the moment. So the service also needs to take care of these low-level details, and this is why Hara greatly simplifies the writing of this service, because now the developers only need to know the details about their devices, their systems, without the burden of needing to know the details about Eclipse hawkBit. The second important aspect by which Hara simplifies the update of embedded devices is visual devices. Visual devices are simple applications. They can be run as Docker images, so in any workstation or machine with Docker installed. And they simply mock physical boards. Now, if any of you has ever worked with physical boards, they are expensive. They take space, actual space in the room. They are difficult to build, at least for me, very easy to break, difficult to repair. They're costly, expensive, but applications are not. We can run applications in our systems, and if something goes wrong, we can just kill the application. So for example, on this slide, we can see the dashboard. This is Update Factory, but any hawkBit-based service will work. We have no devices in here. Now we go here. This is a simple terminal, and you see a Docker command with different parameters. For example, with the virtual devices, we can configure the URL of the service. In this case, it was the staging instance of Update Factory, the tenant, some target attributes, for example, information about the device, and also how many devices we want to run, in this case 10. And then we just simply run the Docker command. We see a bunch of logs here. We're not actually interested in these logs, but we can see some actor keywords popping up, meaning that we are actually using an actors model. And here at the beginning, we see that we are running 10 different devices, which now appear here in the hawkBit dashboards with the different attributes here in the below. Now, this is very important if we want to test hawkBit features. For example, we have used this internally for load testing. Now, historically, load testing has always been an extremely resource-intensive and expensive type of testing, because of course we need to have lots of resources to overload a server. Now with virtual devices, we can run several hundreds or thousands of devices in a simple workstation or in the cloud, have them connect to the same hawkBit server, overloading the server, and testing our features or experimenting with hawkBit under different types of load. Finally, some news about Eclipse Hara. Now, Hara is being used in production. We're using Eclipse Hara as part of the Android client for hawkBit in production for our customers. So most of the features, of the new features of the project are actually driven by what customers ask to us, by the improvements that they want to see in their systems. For example, a very important introduction was the possibility to schedule, download, and update windows in the devices. Now, customers, they have different embedded devices on the field. Connectivity is not always present. Sometimes there is no connectivity. Sometimes the devices are turned off. So it is very important, the possibility to schedule the update and the download of something, of an update artifact. Again, linked to this, we can also configure the number of the download attempts. If there is no network at a given moment in time, it is pointless and meaningless to try to download again a few minutes later. For example, in the Android client, we implement an exponential backoff to allow our devices to try the download in different moments in time, also with very large time windows in between. Of course, we introduce more verbose log messages. This is always useful, especially when it comes to debugging and errors, especially when we have to ask our customers to give the logs, because of course there is an interaction. So the more logs we have, the more verbose and expressive these log messages are, the better it is for us, and the easier it is for us to understand the problem and the reason of the failure. And lastly, we recently introduced the possibility for embedded devices to send target attributes at every polling from the server if these attributes are actually updated. This is very important in the case of sensor readings, for example, when something in the device changes, CPU usage, memory usage, or other important parameters. It is important that the users of hawkBit know at a first glance the state their devices are actually in. And also, of course, if the server requests explicitly these target attributes, the devices are able and capable to send them to the server. So in conclusion, in this presentation, we have seen two main ways by which Eclipse Hara makes it easier for developers to update their devices using hawkBit. The first one is because by design, by construction, it facilitates the integration of native services, so native operating system dependent components that update each device. And the second main way simplifies the testing, which is always useful, it is always a thing, by allowing developers to use virtual devices, so small applications, to test their hawkBit-based server, be it just hawkBit Update Factory or any other hawkBit-based server, without the need for expensive and time-consuming physical boards. So thank you for being here today in the very last session of this track right before lunch. If you have any questions, we can answer them now. Me and Nicola are here. We'll be here today, again, this afternoon. Otherwise, you have our email addresses here. You can just reach out to us in any moment. And here you have a set of useful links if you want to deepen your knowledge on hawkBit and Update Factory, and also on how the Hara DDI client is actually implemented. Thank you.
I have a question.
Please.
You mentioned that something about an actor-based component in there. I didn't quite understand that. What does that mean? Is that important for me to know as an application developer?
OK, so the question was, correct me if I misunderstood, how actors are involved in the implementation of Hara.
What does it mean in that context? Is that an important feature for me to know? Do I need to implement my update logic in a particular way in order to comply with it, or does it pose any requirements on me as a developer?
No, that's the thing. All the actors model implementation is hidden in the classes that Hara is providing. So you, as a user of the library, just need to extend those classes, and you will benefit from the actors model implementation that's behind. Also, if you want to re-implement the same idea in different languages, you can just rely on different actors implementations because there is no heavy use of Kotlin specific concurrency features in the implementation. It's just a standardized implementation of the actors model.
I think that the question from Kai was why we choose the actor-based model to implement an asynchronous communication inside the API. And
Yeah,
that was
what purpose does it serve? Is that
OK, so
for the process?
yeah, the follow-up was why the actors model. Well, there are several advantages from a concurrency point of view. So actors are actually very simple and small components, and all the communication happens through messages. So when you are writing a concurrency system using actors, you will just have to write very small and components with limited responsibility, and all the communication happens through messages. And messages are processed one at a time, right? So you reduce the risk of having race conditions in your data, in the state of the application, because you process the commands one at a time, and you don't have to burden and to worry about thread management, because actors basically just borrow a thread, they process their messages, and then they just return the thread to the pool.
And as you know, hawkBit is a state machine. The entire workflow is based on state machine. And so we thought that making the intercommunication between those states more solid, we just choose the actor-based model to make it rugged. And that was just like an asynchronous way to make the processes to be.
But in general, my naive idea of what I would need to implement is I implement or override a method that we have in one of these interfaces,
yes.
And I will be notified about apply this update, something like that.
Oh yes.
Yeah, that's it.
And there is maybe a callback interface that I would invoke in order to
That's it.
to report the current state.
All right.
You basically just have to overwrite a few callback methods.
If you're using actors underneath, I don't need to care about
You don't need to care about that.
that.
Yes. That was just like an architectural choice that
Yeah.
we have been using like since how long.
Yeah.
Something that is also interesting for you guys, if you have any Android involvement, it's not part of the Eclipse Foundation code base, but also the Android client, the Android service has been published. For transparency, again, this was our choice from day one to have that code public. And again, the way different Linux, so again, this is a JVM-based component, right? And so is it like, for Linux is a plus, but for Linux you have also other components that are taking care of the hawkBit connection in a different way. So it may be an additional way of doing it. I don't know how Linux embedded devices may be or familiar today with JVM usage. We don't know, but that's definitely another way. Eventually, if you have already some Java or JVM-based code running on your embedded device, to actually have an off-the-shelf. And again, it's service dependent, because if you do that on Linux, and you want to write your own service, you may want to use dbus as an inter-process communication, or you may want to use a Qt application to do that. So this is why this is OS dependent. There is no really an effective way. There is no one recipe to make that general. So you got to decide what is your last inch that you want to. But definitely you don't need to care anymore about the DDI side of the
Any other questions? Okay, so let's go to lunch, and thank you again for being here.